The production of dairy milk in surplus seasons surpasses the demand, and therefore there are a variety of methods for extending the shelf life of the milk. The most widely used method for extending the shelf life of milk is by converting it into skim milk powder. Skim milk powder is simply reconstituted and used to make traditional dairy products. This limits the utilization of skim milk powder to the dairy industry, making it a surplus product of this industry. There has been little effort in expanding the utilization of skim milk powder in novel value-added products due to its high lactose content, because 70% of the world is lactose intolerant. One way to utilize this excess skim milk is to hydrolyze the lactose, then concentrate the lactose-free skim milk. This concentrate can then be pumped through the extruder in place of water. Skim milk powder and lactose-free skim milk powder were also used as dry feed bases within the supercritical CO2 extruder to produce protein-rich exudates that utilized the surplus skim milk of the dairy industry. The extrusion process begins by turning on the computer system of the extruder and letting the equipment warm up. Once everything is set, the dry feed is dumped into the hopper of the extruder. The dry feed then flows into the premixing cylinder and then down the chute into the barrel of the extruder. As the dry feed flows through the barrel of the extruder, which contains two co-rotating screws, the dry feed is mixed with the water or milk concentrate to form a dough. The temperature of this dough should be around 85 degrees Celsius. The advantage of using supercritical CO2 extrusion for this process is that we can get a high protein product without causing heat damage due to low processing temperatures. Once extruder conditions are stable, the pressure of the die head can be increased to around 1800 to 2000 psi, and the supercritical CO2, which is kept at 3000 psi, can be added to the products. The supercritical CO2 acts as the blowing agent and results in product puffing. Using concentrated lactose-free skim milk in place of water, which is the solvent in extrusion, we were able to extrude carbohydrate-based sweet and savory formulations that have the addition of lactose hydrolyzed skim milk concentrate. For the second processing method, skim milk powder, or lactose-free skim milk powder, was used as the main component in the dry feed formulation, resulting in exudates that were anywhere from 30% to 68% lactose hydrolyzed skim milk powder based. The 50% skim milk powder or lactose-free skim milk powder formulations were chosen for Gauss analysis. Supercritical CO2 extrusion was used as a non-enzymatic way to catalyze the trans-glycosylation reaction that polymerizes the sugars in the skim milk powder or lactose-free skim milk powder into non-digestible carbohydrates called galactooligosaccharides. Gauss is a prebiotic currently of high interest in the food and nutrition world because it is linked to many health benefits such as reducing inflammation, improving immune function, and improving cognitive functioning. Skim milk powder and lactose-free skim milk powder were used in varying ratios with MPC and sugar in addition to sodium hexametaphosphate to produce in-mouth dissolving puffs. The texture characteristics of these exudates that were MPC-based with the addition of either skim milk powder or lactose-free skim milk powder were analyzed and showed that the desirable in-mouth melting exudates could be produced from both skim milk powder and lactose-free skim milk powder. These products are ideal for both infants and adults suffering from dysphagia. Formulations containing up to 68% lactose-free skim milk powder were able to be extruded.